Hi, good morning. Thanks, Craig. Thanks to ARC for giving me the opportunity to share my experience. Today, I'm going to deliver the topics which is very much in the how IT/OT convergence can help reduce plant process safety incidents. In the topic, I'm going to take two case studies. The first one is the use of 1 out of 2 diagnostics SEAL3 sensors or transmitters. The second case study is on the wireless SEAL2 gas detectors. If you all noticed, or maybe some of you have attended yesterday, Bahrain refinery has actually used these case studies, installing 14 numbers of gas detectors. So today I'm going to elaborate a little bit more on that gas detectors. Okay, I'm from Petronas, 20 hours from here, the other side of the world. We are the 5th champions in Mercedes. We are the proud sponsors of Mercedes, they are champion. And we are the first to set sail LNG carriers. The small, but actually the first to set sail, the LNG, floating LNG. And our business is actually to add values to the oil and gas. And in terms of process safety, if you look at the statistics, about 20 numbers of process safety incidents starting 1971 to 1996, and the numbers are increasing. So we have to do something about it. If you look at to the right-hand side of the slides, the image there, that is actually a Barnesfield incident. And it is actually a very infamous incident. And after the incident, the UK HSC officer, Gordon MacDonald, has actually mentioned 3 statements. There's a statement from him, 1, 2, 3. Do you understand what could go wrong? Do you know what your system are to prevent this from happening? And do you have the information to assure that the system are working effectively? That is his 3 questions. The 4th question is being posed during the instrumentation automation symposium in Texas A&M, which is, what is your role? What is my role? And today, I'm going to add the 5th question, which is, how can we leverage IT/OT convergence to help reduce process safety incidents? Okay, case study number 1. So I'm from refineries, Kerteh. It was a legacy plant, commissioned 1983. And you can imagine 1983, the IEC 61511 was not even there. IEC 61511 was born post-2000, which is an equivalent to ISA 84. So you can imagine the way they built the plant does not really conform. There's a lot of issue, for example, potential having under-engineered safety instrumented function, which can cause dangerous failure to the plant. Take, for example, one case. If I want to protect the furnace against low pressure during the supplying of the pilot line, we are relying on the low pressure sensors to treat the plant. But the sensors at that point of time was only switches or maybe dumped analog transmitters. And this transmitter can fail on demand. And the effect of failing of that transmitter upon actual low pressure, it is catastrophic HSE incident. And we don't want that to happen. That's what can go wrong. So what we are doing is, in this very small case study, we can expand it, we can scale it later on, is first we have to understand the situation. Single sensor, non-smart device can be switches, can be dumb transmitters. So when we do the SEAL study, this is requirement by 61511, which is later on a study has to be done, the study showed that this loop requires SEAL3. What do you mean by SEAL3? SEAL3 means I have to have additional of transmitters. Conventionally, it is 3 transmitters, 2 out of 3. If you look at this configuration, 2 out of 3 is a conventional method of achieving SEAL3. But having requires 3 transmitters as opposed to 1 transmitter in the plant, a legacy plant, old plant, you require additional 2 transmitters. You require additional mechanical design to drill nozzle on the pipe. You have to lay cable. There's a lot of cost. And why can't we find a better solution, cheaper, but not compliant, not compromising the standard, the safety standard IEC 61511? This is where the idea of 1 out of 2. But 1 out of 2 alone, it is actually a spurious. It is very much spurious. So we cannot have a very safe plant, but at the same time, keep on tripping because of you have a double sensor which can trip spuriously. So this is where the idea of 1 out of 2 diagnostics. The 1 out of 2 diagnostics is very, very novel ideas. So in the plant, I have 1 sensors. I need to find another sensors. And I put diagnostic to it. I make it as very smart. The controller is able to differentiate that the transmitter is failing or actually the process hazard. The process actually, there's actually a process hazard. So what is happening is we are actually build 1 out of 2 transmitters. Scenario here, for example, 1 transmitter failed and the controller is smart enough to tell, oh, this is not the process hazard. This is actually coming from the loop, coming from the transmitter. So it tells the DCS to the operator, okay, you have 1 hour to observe these things. You have to override it so that you can call the maintenance guy to actually repair the transmitters. Or if you don't do anything, I will trip the plant. So this is very, very smart way of doing things. So what happened in the plant is, we go to the site. How we actually implement it is, we have, for example, in the plant, in this case, I have 1 trip transmitter, PZA120-1. I also have a monitoring transmitter, PIA121. So I don't want to incur cost. I convert these guys to a trip transmitter, -2 become 1 out of 2, and 1 out of 2 diagnostics. And for the role of monitoring, I use wireless. So a very smart way. Wireless, no cable, it's just a transmitters. So can imagine you can scale up these things to 100 loops, 1,000 loops. It's a cost saving without compromising safety. So this is case. And on top of that, what we are doing is we are having what we call dynamic risk analyzer, which is an IT-driven software based on they're able to actually look at the drift between the sensors. In this case, for example, you have 2 sensors. I can see the drift in between. If there's a drift, I will alert. And this is another example of 2 out of 3 at the same time. If any drift in between the sensors, I will alert and we do the repair work accordingly. And from there, we extend the analyzers to other equipment, to other critical assets, the pump, the motors, and etc. And this is an example of cost saving that we actually obtain from that early detection, what do you call it? Anomaly detection. A very smart dynamic risk analyzer, which is a software to actually looking at all the data, and analyze, and then alert the plant whether there's potential drift, potential issues, or anomaly detection. This is what we have done. This is case number 1. Case number 2 is on the wireless technology in OT domain. We seal-2 certified gas detector to monitor presence of fire or flammable gas. Okay? So what happened before is that the legacy plant, the old plant, did not have proper fire and gas mapping to properly locate the gas detector or the fire detectors for correct and fast detection for the operator to take action. The effect is that if the inaccurately placed detectors, you are not able to detect the hazard early enough that the hazard become major. It was initially minor, but because of the late detection due to the improper placement of the detectors on site, the incident become major. That's a big thing. So what we are doing is, we come up with a fire and gas mapping study, properly locate the detectors so that it can properly, accurately detect and alert the operator fast enough so that the incident instead of become major, it's only minor. It's a big thing for the plant. Now, let me step back a little bit. What do you mean by fire and gas mapping? Fire gas mapping, before to year 2000, it was not there. But because with the presence of IT high computing power devices, with data science and 3D digital twin, we are able to accurately model the plant. We are able to accurately place the detectors to get a correct coverage so that we can get a better detection in case of presence of flammable gas or in case of presence of presence of fire. So we can prevent the event from become major instead of minor. Okay. So in our plant, in our case study, in last year, 2018, we have installed around 19 number of gas detectors. Okay, 19 numbers. But the problem is this. To install, there are two issues that we encountered. Number one, because of legacy plant, issues with cables, no spare cables, congested plant, we have to erect scaffoldings. Scaffolding now is very expensive because you require drawing for the HSE, you require a regulatory body, and so on and so forth. Very costly. And the second issue is the gas detector keep on drifting. And when the gas detector drifting, when there's actually demand, they are not able to detect, and that's it can cause HSE incident. So how we encounter the problem is, we make it wireless. We search in the market. Actually, there is a wireless IIoT technology gas detector presence in the market. Okay? And this guy is wireless. And the advantage of wireless, of course, no cable, no scaffolding, and you actually can quickly deploy that detectors. The second issue is on the frequent drift of the sensors. And these vendors is able to come up with a technology which is a single beam triple waveline versus the conventional method which is two beams. And this technology is what I'm having shown right here. It is actually claimed to be calibrated for life. Okay, let me check whether this claim by vendor is correct or not. So what I'm doing is I do the checking, and actually I installed 14 numbers of wireless detectors in year 2014, and this is the data. The yellow one is the wired detectors using conventional. The blue one is the wireless. You can see the issue is only battery replacement. Of course, wireless require battery replacement. So every 2 years, you have to replace the battery. Okay, that's one we accepted. And you can see the wired one, you can see issue of drifting here and there. So this guy, there's no issue of drifting. So actually a good comparison based on my study of my data. And I'm happy with this performance. Therefore, I am buying additional number of 19s. 12 in 2014, 19 in 2018, already installed. Okay, moving forward, when we consider selection of the detectors, the SEAL 2 is a bonus for us because that is an assurance of the robustness of the transmitters of the detectors against potential failure on demand. That is actually certified. So we are okay. We are very happy. And compliance to the IEC 100.118 wireless, which is actually robust and stable, and satisfies the explosive atmosphere for the plant, which is okay, very good. And it is actually interoperable with existing wireless network because in the plant, we also have wireless HART. We also have wireless ISA 100. So we don't want it to be disruptive against each other. So they are actually can co-present, which is good. And I have that proven in use. I installed in 2014, and the data that I show you. So we are happy with that performance. Okay, to recap, 15 minutes given by Craig. Okay, he did not raise the flag yet, so I'm in time. To recap, the benefits of IT-OT convergence in terms of process safety, case study number 1, to recap. Okay. If I were to use conventional tour of 3, I just follow the conventional, I'm going to spend a lot of money I have to add third transmitter, or maybe second transmitter. I have to do a mechanical tapping for sensor. I have to lay cable, additional I/O, programming, and so on and so forth. This costs easily 50,000, 10,000 US dollar. Can you imagine you have 100 loop, you are saving 100,000 US dollar. 100 loop, no, sorry, 10,000 US dollar, that is cost saving for 100 loop. But without compromising safety. We also have the dynamic risk analyzer that can check the drift of the transmitters. Not only the transmitter, it can be expanded to other equipment, what they call for anomaly detection. Okay, this is case number one. Case number two is the use of fire and gas mapping. After I do fire and gas mapping, I have to install, there's a challenge. So we use the wireless gas detectors, which is very easy to deploy. Calibration, which is calibrated for life, which I've already shown my data. And another plus point of these wireless detectors is that every 5 years, the requirement by HSC is to review back the location of the detectors, whether the hazard has changed or not. If the hazard has changed, I can relocate the wireless detectors to the new hazardous location or to the new place that require the gas detector to be installed. So I don't have to, I have no problem with that. It's very, very much portable. That is the beauty of that wireless gas detectors. Okay? With that, I end my presentation. Thank you.